glance at the night sky from a clear vantage point, and the thick band of the Milky Way will slash across the sky. But the stars and dust that paint our galaxy's disk are an unwelcome sight to astronomers who study all the galaxies that lie beyond our own. It's like a thick stripe of fog across a windshield, a blur that renders our knowledge of the greater universe incomplete. Astronomers call it the zone of avoidance. Renée Kroeger has spent her career trying to uncover what lies beyond the zone. She first caught a whiff of something spectacular in the background when, in the 1980s, she found hints of a potential cluster of objects on old photographic survey plates. Over the next few decades, the hints of a larger-scale structure kept coming. Late last year, Kroeger and colleagues announced that they had discovered an enormous cosmic structure, a supercluster of thousands upon thousands of galaxies. The collection spans 300 million light-years, stretching both above and below the galactic plane like an ogre hiding behind a lamppost. The astronomers call it the Vela supercluster, for its approximate position around the constellation Vela. Renée Kroeger, an astronomer at the University of Cape Town, has spent decades trying to peer through the zone of avoidance. The Milky Way, just like every galaxy in the cosmos, moves. While everything in the universe is constantly moving because the universe itself is expanding. Since the 1970s, astronomers have known of an additional motion, called peculiar velocity. This is a different sort of flow that we seem to be caught in. The local group of galaxies, a collection that includes the Milky Way, Andromeda and a few dozen smaller galactic companions, moves at about 600 kilometers per second with respect to the leftover radiation from the Big Bang. Over the past few decades, astronomers have tallied up all the things that could be pulling and pushing on the local group. Nearby galaxy clusters, superclusters, walls of clusters and cosmic voids that exert a non-negligible gravitational pull on our own neighborhood. The biggest tugboat is the Shapley supercluster, a behemoth of 50 million billion solar masses that resides about 500 million light-years away from Earth and not too far away in the sky from the Vela supercluster. It accounts for between a quarter and half of the local group's peculiar velocity. The Milky Way as seen by the Gaia satellite shows the dark clouds of dust that obscure the view of galaxies and the universe beyond. Gaia Q5 Q8. The remaining motion can't be accounted for by structures astronomers have already found. So astronomers keep looking farther out into the universe, tallying increasingly distant objects that contribute to the net gravitational pull on the Milky Way. Gravitational pull decreases with increasing distance, but the effect is partly offset by the increasing size of these structures. As the maps have gone outward, said Mike Hudson, a cosmologist at the University of Waterloo in Canada, people continue to identify bigger and bigger things at the edge of the survey. We're looking out farther, but there's always a bigger mountain just out of sight. So far astronomers have only been able to account for about 450 to 500 kilometers per second of the local group's motion. Astronomers still haven't fully scoured the zone of avoidance to those same depths, however. And the Vela supercluster discovery shows that something big can be out there, just out of reach. In February 2014, Kroeger and Michelle Kluver, an astronomer at the University of Western Cape in South Africa, set out to map the Vela supercluster over a 6-night observing run at the Anglo-Australian Telescope in Australia. Kroeger, of the University of Cape Town, knew where the gas and dust in the zone of avoidance was thickest. She targeted individual spots where they had the best chance of seeing through the zone. The goal was to create a skeleton, as she calls it, of the structure. Kluver, who had prior experience with the instrument, would read off the distances to individual galaxies. That project allowed them to conclude that the Vela supercluster is real, and that it extends 20 by 25 degrees across the sky. But they still don't understand what's going on in the core of the supercluster. We see walls crossing the zone of avoidance, but where they cross, we don't have data at the moment because of the dust, Kryenkertuig said. How are those walls interacting? Have they started to merge? Is there a denser core, hidden by the Milky Way's glow? And most important, what is the Veles supercluster's mass? After all, it is mass that governs the pull of gravity, the buildup of structure. How to see through the haze while the zone's dust and stars block out light. In optical and infrared wavelengths, radio waves can pierce through the region. With that in mind, Kryenkertuig has a plan to use a type of cosmic radio beacon to map out everything behind the thickest parts of the zone of avoidance. The plan hinges on hydrogen, the simplest and most abundant gas in the universe. Atomic hydrogen is made of a single proton and an electron. Both the proton and the electron have a quantum property called spin, which can be thought of as a little arrow attached to each particle. In hydrogen, these spins can line up parallel to each other, with both pointing in the same direction, or antiparallel, pointing in opposite directions. Occasionally a spin will flip, a parallel atom will switch to antiparallel. When this happens, the atom will release a photon of light with a particular wavelength. One of the 64 antenna dishes that will make up the Meerkat telescope in South Africa. The likelihood of one hydrogen atoms emitting this radio wave is low, but gather a lot of neutral hydrogen gas together, and the chance of detecting it increases. Luckily for Kryenkertuig and her colleagues, many of Veles' member galaxies have a lot of this gas. During that 2014 observing session, she and Kluver saw indications that many of their identified galaxies host young stars. And if you have young stars, it means they recently formed, it means there's gas, Kryenkertuig said, because gas is the raw material that makes stars. The Milky Way has some of this hydrogen, too, another foreground haze to interfere with observations. But the expansion of the universe can be used to identify hydrogen coming from the Veles structure. As the universe expands, it pulls away galaxies that lie outside our local group and shifts the radio light toward the red end of the spectrum. With emission lines separate, so you can pick them out, said Thomas Jarrett, an astronomer at the University of Cape Town and part of the Veles supercluster discovery team. While Kryenkertuig's work over her career has dug up some 5,000 galaxies in the Veles supercluster, she is confident that a sensitive enough radio survey of this neutral hydrogen gas will triple that number and reveal structures that lie behind the densest part of the Milky Way's disk. That's where the Meerkat radio telescope enters the picture. Located near the small desert town of Carnarvon, South Africa, the instrument will be more sensitive than any radio telescope on Earth. Its 64th and final antenna dish was installed in October, although some dishes still need to be linked together and tested. A half array of 32 dishes should be operating by the end of this year, with the full array following early next year. Kryenkertuig has been pushing over the past year for observing time in this half-array stage, but if she isn't awarded her requested 200 hours